Hi, this is Dr. Simon Romero. I'm here to present you the video tutorial for linear approximations. So, linear approximations is a way that we can approximate the value of a function of two variables by using the tangent plane. So the thing that we're going to do is we're going to take the tangent plane at a particular point. And the idea is using the tangent plane, this is the equation of the tangent plane, and transforming it into a function. This function is going to be called the linear approximation. Notice that the only thing that we're doing is we are seeing the tangent plane as a function of two variables, where c is the dependent variable. So if we do that, the thing that we are going to say is that if you take points that are close to AB, if your point xy is close to AB, the value of the linear approximation is going to be close to the value of the function around AB. So let me give you an example. Suppose that we need to compute this number without using a calculator. So the thing that we can do is we can use our linear approximation to approximate this number. And the way that we're going to do it is the following. We're going to first try to recognize two things. The function that we're going to approximate and the point that we're going to center the approximation. In other words, we're going to try to recognize what point is going to be the point that we will take the tangent plane and the function. Now notice that these two things are related because the problem of this particular number is these two decimals that we have right here. So the thing that we're going to do is we're going to represent, we're going to change these two decimals by numbers that we know how to compute the rest of the expression. So if we replace 0.99 by 1 and 0.02 by 0, we will be able to compute the value. That gives us both the point and the function. The point is 1,0 and the function is f of xy equal to x e to the y and everything raised to the 8th. So now that we have that, we're going to compute the equation of the tangent plane. So we know that f of 1, 0 is equal to 1. In order to compute the tangent plane, we need to evaluate the partial derivatives at this point. That's the point of tangency, if you remember. So here are the partial derivatives, and we're going to evaluate at 1,0. Those are going to be the numbers. And now the thing that we're going to do is we're going to take the linear approximation. The linear approximation is going to be just the tangent plane. So we're going to take the value 1, and notice that this value 1 is actually a rough approximation of what is this value over here by replacing by the numbers that we thought that will make this expression a little bit easier, and the rest is going to give you some kind of approximation of the decimals, if you want to say so. So the thing that we have is, now that we have the tangent plane, we are going to evaluate the tangent plane or the linear approximation at the value that is close to the center of this linear approximation. So the thing that we have is 1 times 8 times the difference plus 8 times the difference. And notice that here the difference is minus 0.01, and in the other one is positive 0.02, and at the end it gives you 1.08. If you want, you can try to do it in your calculator, and you will see that this is a pretty decent approximation. And with that, we finish this video tutorial. Thank you very much.